All right, what are we working on today? Inequalities. That means we're going to have to graph and shade, right? Graph and shade. That's what's different from yesterday, right? Yesterday we just graphed. We graphed actual quadratics and then we graphed systems of quadratics. Today we're going to graph quadratic inequalities and then systems of inequalities. So we're going to have to graph and shade. Graph and shade. Okay? What form is this quadratic in? Vertex form, that's right. Okay? Since it's in vertex form, we can easily find the vertex, can't we? Where is the vertex?
Right there.
It moved to the what direction? Right 2 and up 7. Oh, look at that. It magically appeared. It moved right 2 and up 7. What else do we know about this? So it opens down. Now, is this parabola parent function shape? It is not. That's correct. And why is it not? Because there's a multiplier, right? So, first of all, let's find the vertex. Okay? Right 2, 1, 2, up 7. 1, 2, 3, 4, 5, 6, 7. So that's my vertex. Now, I know it opens down, right? Now, if this 3 wasn't here, I could go over 1, down 1. Over 2, down 4, and over 3, down 9, right? Because 1 squared is 1, 2 squared is 4, 3 squared is 9. I know it's not parent function shape, though, because this multiplier here, but I still know how to graph it without looking at the calculator, because instead of going over 1, down 1, I'm going to go over 1 and down 3 times that.
3.
I can't go over 2 and down 4, but I can go over 2 and down 4 times 3. So over 2, down 12. I can't go over 3 and down 9. I would have to go over 3 and down 9 times 3. So 27, but I can't do that, right? There's not enough room. But how many points do I need to make a parabola? 3. Right? Technically 3. 5 lets me see it really easily, right? But I technically need 3, and since I have 3, that's fine. Right? Now, what do I have to be careful about when I go to graph this? What does that tell me right there? That tells me I have to draw a dotted line. Right? What makes it dotted? Less than or greater than. What makes it solid? Less than or equal, greater than or equal. That's a solid line, right? Okay. So I'm going to draw a dotted line. Now, we also said we have to what? Also shade, okay? Now, with lines, it was easy, right? If it's greater than, it's above, it's less than or below. Bam, right? Quadratics is not always easy because there's not an above and below. What is there? Inside or outside. That's exactly right, okay? So I have to decide where to shade. Do I shade inside or do I shade outside? Well, do you remember how we decided in the beginning with lines when we weren't ready to just say greater than is above and less than is below? We chose a point, right? What's the easiest point to choose? The vertex. No. Good guess. What's the easiest point to choose? 0, 0. Yeah, the origin, right? The origin is the easiest point to choose. Now, is this origin inside the parabola or outside of the parabola? It is outside of the parabola, so keep that in mind, okay? So what I need to do is I need to substitute a 0 in for x and a 0 in for y. So what is 0 minus 2? And what is negative 2 squared? And what is 4 times, oh geez Louise, what is 4 times negative 3? Negative 12 plus 7, I don't know why I wrote a 4. I was just excited about 4. Negative 5, right? So is 0 less than negative 5?
Yes. No. Wait, yeah.
Is 0 less than negative 5? No, right? It's not. So wherever that point was that I chose, which was the origin, I can't shade there because the answer is no. So where should I shade for this parabola? Because where was the point that I chose? Outside. So that's a no, so I shade inside instead. Okay? Does that make sense? So how does it change when I make it a system? Well, I still have to graph each one of them individually, right? Okay? But when am I going to shade? At the very end, right? I'm not going to shade after I graph each one. I'm going to shade at the very end. I'll think about where I would shade if I was going to shade, but I'm not going to shade till the end. So where does this one move compared to its parent? Up 5, right? So up 5. 1, 2, 3, 4, 5. And is it parent function shape? Yes, because there is no multiplier, right? So from here, and it opens up, right? It's a positive number. So over here I can go over 1, up 1, over 2, up 4, because 2 squared is 4, and then over 3 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's off the graph, but it's still close enough I can see it, right? And again, I know parabolas are symmetric, so I can go ahead and draw those points in. Now, is this dotted or solid? It is dotted. Now, I'm not going to shade, but if I were to shade, would it be inside or outside? Well, let's pick 0, 0, right? 0 is greater than 0 squared plus 5. Well, 0 squared is 0, so 0 is greater than 5. That's a no. So I don't shade where the origin is, and where is the origin? Outside, so where would I shade? Inside. So I'm just going to tell myself that's where I would have shaded. Okay? All right. Now, let's graph this one. Where does it move compared to its parent?
Down.
Up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. But what? It opens down, right? That opens down. So over, is it parent function shape though?
Yeah.
Yes. So over 1 down 1, over 2 down 4, and over 3 down 9. This time can I go over 4? Yeah, how far will I go down? 16. And again, I know parabolas are symmetric, so I'm going to go ahead and put all my other points in. Now, is this one solid or dotted? Definitely solid, because it's or equal to, right? Now, where's the origin this time? For the blue one, it's inside, right? So 0 is greater than or equal to negative 0 squared plus 9. So 0 is greater than or equal to 9. No. So where do I shade for the blue one? Outside. Now I have my whole system graphed, and I have to decide where to shade now. I have to shade inside the pink one, but outside the blue one.
So now no football.
So just right here, right? Does that make sense? Questions on graphing just one, and questions on graphing a system. What are the things that you've got to remember? Dotted or solid, opening up or down. You need to remember your transformation rules, so if you need to use your transformation foldable, you may. Are you allowed to put these in the calculator and look at the table to know where to plot the points?
Not Colton.
I would rather you know your transformation rules, but am I going to stop you? No, I'm not, because I want you to get the answer right. Does that make sense? Okay? All right, then let's do this one. This is our last example for today. Am I graphing this one? How do you know that? There's not a y, right? It's not greater than or equal to y. It's not less than y. It is greater than 0. So how am I going to solve it then? We have to solve it algebraically, right? We have to solve for x. We're not trying to solve by graphing. We need to solve it algebraically. Okay? So, what does that mean? I have to solve this quadratic. Should we try to factor it first? That's usually pretty quick. Yeah? Okay. What two numbers multiply to be 7 and add to be 6?
6 and 1. Wait. 7.
Has to multiply to be 7 and add to be 6.
7 and negative 1.
Oh, but 7 and negative 1 don't multiply to be 7, right?
Nothing.
Nothing. So how are we going to solve this?
You can.
You can. You can.
It's only the way.
Uh-huh. Okay, so let's see. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. X equals negative 6 plus or minus the square root of 36 minus 28. What is 36 minus 28? 8 over 2. I don't know the square root of 8, but I know that 8 is 4 times 2, right? And I know the square root of 2, don't I? So x equals negative 6 plus or minus 2 root 2 over 2. So what can I simplify here?
The 2.
The 6, the 2, and the 2, right? So what does that simplify to?
3.
So negative 3 plus or minus root 2. But you know there has to be some shading going on, right? Well, this time I just have a number line. I don't have a graph because, like you said, I don't have a y. But I do have an x, right? So I just have a number line. So where does that go? Do you remember me telling you that sometimes this is a perfectly acceptable answer because it's the exact answer, and sometimes we need to go to a decimal? Guess what? So negative 3, let's see.
How do you know the answer?
What does it do?
What is it? It's negative 2.3458.
Oh, I think my calculator's being rude.
So far. No, it's not.
I don't know. Let's try this one. Let's add a p to the calculator. I need negative 3 plus the square root of 2. So negative 3 plus the square root of 2 is negative 1.586. Are you okay with that? So x equals negative 1.586. But I also have negative 3 minus the square root of 2. Negative 4.414. So here's 0. Here's negative 1.586, and here is negative 4.414, right? Now, if you'll remember on when we have the number lines, first of all, did any of you notice that I went from here just to here? I didn't carry my inequality sign along. Okay? There's a reason for that. First of all, we can get real confused by that. Okay? I chose not to get real confused. I chose to take it to we're solving for x. Okay? Because at the end of the day, I know that based on the fact this is an inequality, I know my answer can either be between the two numbers or outside of the two numbers. That's the only options. It's not ever going to be just this side. It's not ever going to be just this side. It's either going to be between the two numbers or outside of the two numbers. So what I need to find is the two numbers first. Okay? Now, how do you think I'm going to decide if I shade between the two or outside the two?
If they're negative.
Did you notice I put a 0 on the number line?
Yeah.
Let's put a 0 in. Just like we've been putting in a 0 up here, let's put a 0 into this equation. 0 squared plus 6 times 0 plus 7. So 0 plus 0 plus 7. 7 is greater than 0. Is that true? Well, since that's true, I know, well, first of all, I already knew that these both had open circles. Do you remember that? Why do I know they both have open circles?
Not equal to.
Because it's not equal to, right? It's just greater than. Okay? What I could do is I can either choose to shade between or I can choose to shade on the outside. Where do you think I'm going to shade? When I plugged in a 0, what was true about it? It was true, right? 0 was true. 7 is greater than 0. So I know for sure I'm going to shade over here. But since I shaded over here, well, where else do I shade? Over here. Okay? So my answer then is x is less than negative 4.414 or x is greater than negative 1.586. Does that make sense? Now, what if this was a less than sign right here? How would that change my answer? Would it change my 2 points? No. Where would I shade? I would shade inside because this would say 0 is less than, or sorry, 7 is less than 0, and that's not true. So I wouldn't shade where the 0 is, I'd shade on the inside, in between the two numbers. And this would be x is greater than that number, and x is less than that number. Do you see why it would be and? Because it would be in between the two? Does that make sense? Do you have any questions about this? Any questions about the graphing too? Any questions about the not graphing, the algebraic? You good?